Hi everyone, I'm Madhu. So friends, this is question number 2 from exercise 7.1 of chapter number 7, triangles. So the question is, ABCD is a quadrilateral in which AD is equal to BC. So as you can see the figure that ABCD, it is a quadrilateral and AD is equal to BC. This line segment AD is equal to BC. Then and angle DAB is equal to angle CBA. So you can see that angle DAB, this angle is equal to angle CBA, this angle. So these both angles are equal and these both line segments are equal. Prove that first part. So there are three parts in this question. First one is we have to prove that triangle ABD is congruent to triangle BAC. So triangle ABD means this triangle. ABD, this complete triangle is congruent to the triangle BAC, this triangle. So this triangle and this triangle, we have to prove them congruent. So this is the first part. So how we are going to start? So you can see that in the question it is given to us that AD is equal to BC and AD is the part of the triangle ADB and BC is the part of triangle BAC. So hence we can write that AD in the triangle ABD and triangle BAC, AD is equal to BC. AD is equal to BC. And what reason what we are going to give? It will be in the bracket we will write it is given to us, because it is given in the question that they both are equal. So we need three conditions for proving them congruent. One we have got, one side we have got equal. Now we need two more conditions. So you can see that it is told in the question that angle DAB is equal to the angle CBA and angle DAB is the part of this triangle and angle CBA is the part of this triangle. So hence we can write as it is angle DAB is congruent to the triangle CBA. And what reason what we are going to give here? The reason it will be given because it is also given to us that these both angles are equal. Two conditions we have got. Now we need one more condition for proving them congruent. So what can you think of? So in both the triangles, one side is common. You can see that AB, this line segment is common in the triangle ABD and this AB line segment is common in the triangle CBA. In both the triangles, this line segment is common. So hence we can write AB is equal to AB and the reason will be it is common. So we are going to write common. So now we have got three conditions. We have got two sides and one angle. So they are congruent. So we can write therefore triangle ABD is congruent to triangle BAC. And by which congruency rules they are congruent? You can see that there are two sides and one included angle. So hence we can write they are congruent by SAS, congruence rule. They are congruent by side angle side congruence rule. So this was the first part. Now let's move on towards the second part. So friends, there are three parts in this question, second and third part. Second part is we have to prove BD is equal to AC. We have to prove BD, this line segment, is equal to AC, this line segment. So right now in the first part, we have just proved that this triangle ABD, it is congruent to the triangle CBA. So you can see that BD and AC are the part of those two triangles. So hence we can write that BD is equal to AC and it will be by CPCT, corresponding parts of congruent triangles, because we have proved the both triangle congruent. Third part is angle ABD is equal to angle BAC. Angle ABD means this triangle, this angle ABD, this angle, it is equal to the angle BAC, means BAC, this angle. So we have proved these angles, triangles equal, congruent right now. So they are also part of these both triangles. So hence we can write that angle ABD is equal to angle BAC also by CPCT, because they are the corresponding parts of the triangles we have proved congruent. So we can write BD is equal to AC BD is equal to AC and angle ABD is equal to angle VAC, and the reason for both will be by CPCT, corresponding parts of congruent triangles. So by CPCT they are equal. So this was the second and third part. So this was question number 2 from exercise 7.1. Now let's move on towards our next question.